In episode 42 of the SOC Level 2 training series, we are going to go through the basic static analysis room that is a part of the malware analysis module inside of the SOC Level 2 pathway of TryHackMe. And this is where, after this point, we're going to actually start analyzing source code as well as applications or malware, so to speak. And this is where everything that we've talked about so far, all of the nuance, the detailed information that we covered in all of the last videos, the last, I think, like 3 or 4 episodes that we did inside of malware analysis, all of those things are going to come together and we're going to start analyzing these various malwares that are presented to us. And hopefully we'll be able to find the answers to the questions that we have and everything. And hopefully it'll be a great learning experience for both you and me. And the outline that we have, the overview for this video is going to obviously be the introduction to the room, the setup of the lab and all the virtual machines that are going to be assigned to us, string search, so searching for strings, fingerprinting malware, signature-based detection, leveraging the PE header, and the conclusion. There'll be some final thoughts and we'll review everything and you'll be dismissed for the day. This is a subscriber only room that's inside of TryHackMe. So you do need a paid membership inside of TryHackMe to be able to access the virtual machines and everything else that's available here. However, you can just follow along with everything that we're talking about because for the most part, everything that we're doing here is accessible to you. Whether you're running a Mac, a Windows, or a Linux computer, you should be able to, at the very least, follow along with the information and try to do some of these things on your own computer. That being said, if you're going to analyze malware, so you really have to understand that it needs to be inside of a sandbox environment, inside of a controlled environment. You should not be running malware. You shouldn't be downloading and running malware. It's I highly advise against it. So just keep that piece in mind. It's that little piece. Keep that piece in mind because I don't want you to accidentally go ahead and run malware on your computer and then you get held up at ransom or something, God forbid, something bad happens, and we just don't want that to take place. So that's pretty much what we have for the overview of this video today. And let's jump into it. If you're serious about your CySec education and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into basic static analysis. In all of the previous rooms of this module, we talked about the basics of computer architecture and the assembly language. And those topics are essential building blocks to learning malware analysis. But now we're going to start analyzing malware starting from this specific video onward. The prerequisites are the Intro to Malware Analysis, the x86 Assembly Crash Course, and the Architecture Overview. These are the 3 episodes prior to this particular episode. Or I think it's actually the one right before this one was analyzing PE headers, portable executable headers. And then prior to the portable executable video were these 3 videos. So everything that we talked about so far is basically the build-up to what's going to be happening from now on, which is where the analysis of malware is going to start. The first step in this process is to look at the properties without running the malware, and this is called static analysis. So think of it as staying in its original state. It's static, it's not moving, right? The malware is a static state and it's not running. And then we're going to talk about the basics of this. I've actually done a similar video to static analysis in, I think it was the Secure Software Development Lifecycle, which is a part of the security engineering module, which is the security engineering playlist. So you can go ahead and find that as well. We're going to be talking about lab setup, everything that we got to do to actually prepare for this, searching for strings in malware, fingerprinting malware through hashes, signature-based detection mechanisms, extracting useful information from the PE header. And without further ado, as I like to say all the time, let's move on to the next task and see what we can do to set up the lab for malware analysis. Before we actually analyze any kind of malware, you really have to understand, as I stated in the beginning in the intro, that malware is destructive, and when you're trying to analyze malware, there's a high chance of damaging the environment in which it is being analyzed, meaning your computer, right? So the damage can be permanent, and it might take more effort to get rid of this damage than the effort that it was made to analyze the malware. Therefore, creating a lab setup that can withstand the destructive nature of the malware is necessary. And the virtual machine concept is why this is so important, and this is why I like TryHackMe so much, because they have a bunch of virtual machines for pretty much every single room that you would go into, that you can use the virtual machine as that controlled environment so that you can go ahead and analyze malware, do hacking exercises, all of those things without really having to worry about ever infecting your own computer. A lab setup for malware analysis requires the ability to save the state of a machine, also known as a snapshot or an image, right? And revert it to that state whenever required. The machine is thus prepared with all the required tools installed, and its state is saved. After analyzing the malware in that machine, it is restored to its clean state with all the tools that were installed. This activity ensures that each malware is analyzed in an otherwise clean environment, and after analysis, the machine can be reverted without any sustained damage. With virtual machines provide an ideal medium for malware analysis. Some famous software used for creating and using virtual machines are the Oracle VirtualBox and, of course, VMware Workstation. And I also I've described various ways that you can download and install Linux images inside of the Linux Plus playlist. I believe it's in the first episode in part 3. Maybe it's it's in the first video in the first episode, part 3 of the overall lecture, where we actually go through the installation of Linux, and you can do the same thing, and you can download an ISO image, use VirtualBox or VMware to install it on top of your current operating system, or you can install it on a USB thumb drive, which is what I prefer to do, and I can launch that USB thumb drive from any computer that supports virtual machines without having to download VirtualBox or VMware or anything like that. These applications, these ones, VirtualBox and VMware, they create snapshots and revert to them whenever it's required, making them well suited for malware analysis. And the following steps portray the usage of this. So create a fresh virtual machine with a new OS install, also known as get an ISO image from your favorite OS, and then install it using VMware or VirtualBox. Set up the machine by installing all of the required analysis tools in it. When you do Kali Linux, for the most part, it has a lot of really good stuff that's already installed in it. And there are different versions of Linux that are designed for different things. So Kali Linux is specifically for penetration testing, so it's for offensive security. And then there's the defensive security of Linux, which I think is actually one of the ones that we're going to be talking about. I think it's called REMNUX, REMNUX, and then there is another one, I forget what the name of it is. I will talk about it in literally just a few seconds. Then you take a snapshot of the machine, copy, download the malware samples inside the virtual machine to analyze it, revert the machine to the snapshot after the analysis completes. So this part is very, very important, right? So once you've installed the machine and you've installed all your tools and everything that you need, you take a snapshot of the machine, an ISO image, right? You take essentially a copy of what the overall machine is before you download the malware and run it, right? And then you save this snapshot so that whenever you run the malware, if anything happens to the machine, you can just revert back to that original snapshot by reinstalling it, right? So following these steps ensures that the virtual machine is not contaminated with remnants of previous malware samples when analyzing the new malware. It also ensures that you don't have to install your tools again and again for each analysis. Selecting the tools to install your malware analysis can also be hectic, and one can use one of the freely available malware analysis virtual machines with pre-installed tools. So there you go. Flare VM was the one that I was talking about. It's a Windows-based virtual machine that's well suited for malware analysis, previously also known as FireEye. It contains some of the community's favorite malware analysis tools. It's customizable. You can install any of your own tools in the VM. It's compatible with Windows 7 and 10. And for a list of the tools that are already installed in it, you can just visit the GitHub page for Flare VM or the Mandiant blog for Flare VM. And since it's Windows-based, it can perform dynamic analysis of the Windows-based malware, which is when you actually run the malware and then you analyze it and you kind of watch to see what the malware does. An instance of this is attached to this room that I'm in right now for performing practical tasks. And if you don't have access to TryHackMe, you can just go download Flare VM and use VirtualBox or VMware to install it. So not hard to do, and you can get access to everything that we're going to be talking about. I've already clicked the start machine, so all of that is going. And there's a directory that's named mal on the desktop, which contains malware samples that we would be analyzing for this room. Another one is Remnux, which is the Linux version of the analysis OS, right? So it's reverse engineering malware Linux. And it's Linux-based malware analysis created by Lenny Zeltzer in 2010. More people joined the team to improve upon that distribution. Like Flare VM, it includes some of the most popular reverse engineering and malware analysis tools pre-installed on it. So when you actually download and install Remnux, you get all of those tools installed on it as well. It helps you save time to what would otherwise be spent in identifying, searching for, and trying to install those tools. And details for those are, of course, on the GitHub and the website for their distribution. The website in this particular case is the Remnux website, remnux.org. So very, very easy to access. And it was previously used in the Intro to Malware Analysis room. We actually have used it already, and we're going to be using it in future rooms, in future videos. So we already have this going. The virtual machine is already running. You can see that my IP address has been assigned to me. This is the administrator username and the password that we have. So in case you do have access to TryHackMe and you want to remote desktop into the virtual machine, these would be your credentials with the exception of the IP address. The IP address is going to be dead essentially by the time that I'm recording this video. When I finish recording, I'm going to crash the machine. I'm going to take it down basically, and that IP address will no longer be accessible. But the username and password for this particular room should exactly be the same. So it's just whenever you launch your virtual machine inside of TryHackMe, you'll get a different IP address that you can connect to should you choose not to use the browser-based virtual machine. I'm going to be using the browser-based virtual machine, so it's going to keep it a little bit simpler for us. Virtual machine is already up and running, so let's go into the next section. Okay, in the Intro to Malware Analysis room, which was the first room, the first video inside of the Malware Analysis module. So if you backtrack, I think it's 4 videos before this particular video, then the title is going to say Intro to Malware Analysis. So that's basically the video that we're referencing. We identified that searching for strings is one of the first steps in malware analysis. A string search provides useful information to malware analysts by identifying important pieces of strings present in a suspected malware sample. To learn more about this, we can look at another room that's dedicated to strings, and let's see if I've already done it. Mal strings. I've actually not done this room before, so that's another thing that we can kind of mark for the future. This is also a subscriber-only room inside of TryHackMe. So a string search looks at the binary data in the malware sample regardless of the file type and identifies sequences of ASCII or Unicode characters that are followed by a null character, also known as a none character, like a non-existent character. Wherever it finds such a sequence, it reports that as a string. And this might raise the question that not all sequences of binary data that looks like ASCII or Unicode will be actual strings, which is correct. Many sequences of bytes can fulfill the criteria mentioned above, but are not strings of useful value. They might just include memory addresses, assembly instructions. Therefore, a string search leads to many false positives, FPs. These false positives show up as garbage in the output of our string search and should be ignored. It's up to the analyst to identify the useful and ignore the rest. So this is where an eye that has been developed through experience and through practice and all of those things comes in handy, right? So if you've never done this before, if you've never analyzed strings before and you don't know what you're looking for, you're going to have a hard time with this, which is why you want to practice very frequently. There was a comment that came in through the community of somebody saying, how do I go from studying to execution? And this is it. This is it right here. If you're watching this, I forget the username, so I apologize, but you should know that I'm talking about you because you asked specifically on how to go from studying to actually practicing and executing. And this is how you do it. You download Flare VM or you download Remnux, and then you go through the tools that are available and you do something like this inside of TryHackMe, where it's literally a lab environment where you're practicing the theories, practicing the concepts and the philosophies so that you get actual experience in your fingertips, right? So this is how it all plays out. And this is how you develop that eye that can actually identify useful strings and ignore the rest of them. So what to look for? Since you have to identify actual strings of interest and differentiate them from the garbage, it's good to know what to look for when performing a string search. A lot of useful information can be unearthed in a string search, and these artifacts are the indicators of compromise. IOCs, you're going to hear this a lot if you haven't heard of that phrase yet. And indicators of compromise, literally as they say, they are signs that you've been compromised, right? They're indicators that you've been compromised. Windows functions and APIs like set Windows hook, create process, internet open. These are commandlets that exist inside of PowerShell, inside of the Windows structure. They provide information about the possible functionality of the malware, right? So set a Windows hook, create a process, open internet, right? So IP addresses, URLs, or domains can provide information about possible C2, which is also known as command and control, where there is a remote server that somebody has connected to our local machine from that remote server. Most likely it's like a proxy server because they don't want us to backtrack to their actual location. But that remote server, that C2 connection, is how they are interacting with our local machine, because they have this reverse shell and they can send commands and they're extracting data and doing a bunch of stuff. WannaCry is one of the common stories, the popular examples that is used. It has a kill switch domain that was found using a string search. So that's how they detected WannaCry. Miscellaneous strings like Bitcoin addresses, text used for message boxes. This all helps to set the context for further malware analysis. A basic search that can be done using the strings utility, which is pre-installed in Linux machines, and it can be used for basic string search. Similarly, the Flare VM has the strings.exe. A lot of times what you see, so for example, netcat in Linux is nc for netcat, but then inside of Windows, it's nc.exe. So that's like really the biggest difference for many of these utilities that exist on both of the operating systems. It's just that on Windows, it has an exe at the end because it acts as an executable application. In Linux, it's just a command line utility that you can refer to and you can call on it by just using its name. They do the same task, right? This utility is part of the sysinternals suite, and that's been developed to actually analyze different aspects of Windows machines. We already have a video on sysinternals on this channel, so you can go ahead and check that out if you don't know what that is. Details about the string utility can be found in the Microsoft documentation. The utility comes pre-installed in Flare VM, and the good thing about it is that it can dump strings to a file for further analysis. So it can actually display it onto the screen for you, but it can also dump it into a file for future analysis. Not necessarily further analysis, but if you need to refer back to it without actually running it, or if you need to create a report and send it to your manager, so on and so forth, it can output everything into a file for you. So if you want to refer to the strings utility, you would just do strings, and then you give it the path to the binary, which is essentially the malware, path to the malware that you want to analyze. And there are other tools that can be used for string search. For example, CyberChef, which is amazing. I love it, absolutely. There's a desktop version of it. There's also the website that you can access by just Googling CyberChef, and it's the first one that pops up. It has a recipe. So inside of CyberChef, it's a chef, right? So it has recipes. And there's a recipe inside of CyberChef that can search for strings. And PE Studio is another one that we used in the last video, I want to say. It provides a string search utility. It also provides additional information about the string, like the encoding, the size of the string, offsetting the binary where the string was found, and a hint to guess what the string is related to. It also has a column for blacklisting, which matches the strings against some signatures that previously have been downloaded and configured. So this is what PE Studio, the screenshot, kind of looks like. If you don't know what this is or what it looks like, what it's supposed to do, refer to the last video for the portable executable analysis, the PE analysis, and you'll be able to get some examples of how PE Studio works. But I mean, that's basically it, right? So on the desktop, you can see right here, this is the path to the malware. And then there are indicators inside of it as it's being analyzed, the DOS header, DOS stub, etc., etc. And then there's a strings tab right here that if you click on it, it'll actually show you the value of those strings, for example, whether or not they're on a blacklist, etc. So that is pretty much it. And then these are the values of the strings, right? So query performance frequency, virtual protect, device IO control, terminate process. These are all the things that have been extracted that are not BS jargon, as we talked about a few minutes ago. When you are looking at strings, instead of you having to actually just run strings and then go through everything that's been pulled by the strings utility and try to determine which one is useful, if you use a tool like PU Studio, it literally pulls all the things that would actually be useful to you. Open clipboard, close clipboard, set clipboard data, empty clipboard, send input, all those things. You don't have to use your naked eye to be able to find them. It finds them for you and it lists them. So there are a lot of utilities that make our job easier when we're doing these types of activities, and it would be in your best interest to leverage those utilities. It's not a bad idea to learn how to do it through the naked eye using just a command line. And it's probably actually a good idea to honestly do it so that you can just kind of enhance your experience. But there are tools that can make this easier for you. So this can be done by selecting strings, as we already talked about it. We can learn more about these APIs using resources like Mal API or MSDN. So these are API calls. These are things that you see right here. Those are API calls, and you can learn more about each one of their functionalities by just going through those pages, or you can literally just Google, hey, what does open process do, right? And I mean, that one is kind of a gimme because it tells you that it's opening a process. But just in case you don't know what the other ones do, you can just Google them and then you'll learn. So there's something called an obfuscated string. So searching for strings is one of the most effective ways. And in case of the WannaCry ransomware, effective use of this can often disrupt malware propagation and infection. And the authors know this, so they don't want a simple string search to mess up their activities. Therefore, they will deploy techniques to obfuscate strings. And obfuscation is basically trying to murky it up, right? Trying to disguise it. That's another good way of saying that when you obfuscate something, you're trying to disguise the string so it doesn't look like a basic string that you can actually just read and be like, oh, okay, this guy's trying to open a process, right? Malware authors use several techniques to obfuscate the key parts of their code, and they often render a string search ineffective, meaning you won't be able to find much information when you just search for strings. Mandiant, also known as FireEye, launched Floss to solve this problem. And Floss stands for the FireEye Labs Obfuscated String Solver. I always wonder what came first, the acronym or the value, right? Because it's like, it's so convenient that this ends up being Floss. Like, it has to be the acronym, I feel like. I don't know. Anyways, it uses several techniques to de-obfuscate and extract strings that would not be otherwise found using a simple string search. And the types of strings that it can be extracted and how it works can be found on their blog post on Mandiant's website. And I'll actually open this because I know we're supposed to use Floss in a little bit. So to execute it, you literally open the command prompt, go to the desktop directory. From there, you can use the command Floss. And then if you do -H, it'll bring the help menu, the help page for you. And you can use the following command to search for obfuscated strings in a binary, Floss, no static strings, and then the path to the binary. And the command might take some time to execute. That's always good to know. And you might see what appears to be some error messages before the results are actually generated. So now what we're going to do is we're going to actually open the virtual machine, go to the malware or the mal file on the desktop, and look at which one. We're going to look at the obfuscated strings found in 2, 5, and 6. Which of these contains the string DBG view? So the answer is going to be either 2, 5, or 6, and we're trying to find DBG view exe by running Floss. So let me go ahead and I'm going to zoom out of this, or actually, you know what? I'll do this. I'm going to open up the virtual machine because it makes it easier for you to read if I stay zoomed in like this. So I'm going to open up the virtual machine, but I'm going to open it up inside a new window. And then this way I can now minimize this, and then the new window, there we go. This is going to be our Windows prompt or Windows virtual machine. And now we can actually reference our question here as well. And the command that we're running basically is something like this. But let's see. So we're trying to find obfuscated strings found in that. So that's basically it. What does the hint say? It says use Floss to extract obfuscated strings. It can be executed from CMD after navigating to the desktop. So pretty simple instructions for us. So this is a Windows machine. There are a few different ways that you can open CMD. If you actually have access to keyboard shortcuts, which I don't think I do, because if I do CR, yeah, so usually when you do Control R, it'll open up the run prompt for you, and then from there you can search for CMD. But if you click on the Windows machine or the Windows logo at the bottom left usually, and you can just type in CMD like that, and then it should be able to open it for you, and there it is. So it's actually starting the search. There's the command prompt. So I will open up CMD, and here we go. Now I am inside the user's administrator location. So if I do, I think it's actually dir, because ls doesn't work for CMD, and then there's the desktop. So if I go into desktop, I am now inside of the desktop. CLS is clean screen, so clear doesn't work inside of CMD. And so now if we do dir, we'll see that there is a mal directory right here. So we will go into the mal directory, we'll clear the screen one more time, and now inside the mal directory, we have 1, 2, 3, 4, 5, and 6. Now, what we're going to do is we're just going to run floss, and then the command itself was what? It was floss no static strings, and then give it the path to the binary. So in this case, if I do floss -- no static strings, and then the path to the binary is essentially this, like where we are right here. This is the full path, and then it ends with 1 or 2 or 6 or whatever. And we're supposed to analyze what? We're supposed to analyze 2, 5, and 6 are the ones that we're analyzing. All right, so here we go. Here's the path to the binary. It's going to be C, users, administrator, desktop, and then mal, and then we'll do 2 first. I'm going to press enter, and it says it's going to take some time, so not exactly sure how long it will take. So floss decoded 0 strings, execution after that many seconds. Okay, I mean, that was easy. So we'll do another one. I'm just going to press up on my keyboard to bring the command up. And then now I will do 5 at the end of it. Press enter right there. Let's see if anything comes up for this one. And this might, nope. Okay, so I'm going to guess the answer is 6 because those two didn't give me anything. But let's just run 6 and let's see what, there we go. Now we're getting some information onto the screen here. And we're looking for 5 something. Okay, so this is actually working because the previous ones found nothing for us. So I feel like the answer is going to be 6, but I'm going to wait until the result actually shows up, and then we'll know for sure. But obviously, if the first 2 didn't work, then it's going to be the last one, which is what? Number 6, right? 2, 5, and 6. So let's try 6. The answer should be 6. There we go. That's the answer. It found 1 decoded string. So let's go ahead and zoom in on this a little bit so we can see what's up down here. So far, that's the only decoded string that is found. We will come back if we find, or when we find, the official answer. Oh, boom, there we go, dbg view exe. So it found it multiple times inside of the binary named 6. So there we go. That was the answer, and we found it using floss. Great. So let's go to fingerprinting malware. When analyzing malware, it's often required to identify unique malware and differentiate them from each other to see which ones do what, basically. And file names don't work because obviously you can very easily change the file name, and you can duplicate things easily, and you can even change hash values really by adding like a very basic addition to the code, which does nothing functionality wise, but then it'll end up changing the hash value. But in this particular case, we're actually going to be looking at hash functions to identify a malware sample, and it takes the file data of arbitrary length as input, and then it creates a fixed length unique output based on the file contents, and it's irreversible, and you can't recreate the file's content using the hash. So this is one of those things that sometimes gets confused with encryption, and a hashing algorithm is not an encryption that can be decrypted, right? So you can't reverse a hash. I've done multiple videos on hash values and hashing algorithms. So if you refer to the cryptography section of, I want to say it's SOC level 1, and you'll get some really, really good descriptions of what hash values are and what they do. And then there's a lot of different demonstrations of hash values and rainbow tables and so on and so forth. So hash values in general, right, can't be reversed because you can't decode the hash. But what you can do is you can try to compare it against a database of stored hashes. So imagine somebody has 10 million unique hashes stored inside of a database with the plain text equivalent of what that hash means, what the text value of that hash is. And the only thing you can do is you can take your hash value, compare it against those 10 million hashes to see if they exist in that database. And if they do, you'll find the plain text value. That's the only way that you can find it. You can't decode the hash, right? So that's kind of like the key unique feature about hash values. They have a very low probability, which is practically zero, of two files having the different content but the same hash. That's another thing that's very unique about it, is that for the most part, especially when you use SHA-256 and above, SHA-512, when you use these advanced hash algorithms, it's very, very difficult, almost impossible to find the same hash value dedicated to two different plain text values or two different applications, etc. So it remains the same as long as the file's contents remains the same. That piece is very important. Even a slight change in the content will result in a different hash. It might be noted that the file name is not a part of the content. Therefore, changing the file name does not affect the hash of a file. So that's the key element here that we're going to be focusing on, because you can change the file's name so that it doesn't show up in the database of a security tool, right? Let's say the security tool is looking for malware.exe, and then you change it to, I don't know, content.exe, whatever. I couldn't think of a clever name. But you take the same exact malware and you change the name from malware.exe to content.exe. Now, the security appliance is looking for malware.exe if it's just looking for the name. So content.exe won't show up as an alert. But if you set it to search for the hash value instead of the name, then it is more effective, and then you can change the name to whatever you want, but the hash value stays the same, therefore we can detect it. So they're also used to store passwords to authenticate users. In malware analysis, hash files can be used to identify unique malware. Search for this in different malware repositories and databases as an indicator of compromise. And VirusTotal is one of the more popular ones, and I use VirusTotal in my personal life all the time. When I get an email that seems a little bit fishy, or something happens where I'm like, I feel like this might be a bad URL or something. So I'll copy the URL without actually clicking on it. I'll copy the value of a hyperlink without actually clicking on it, and I'll go to VirusTotal and I'll check to see if it's in their database. And sometimes it is, right? And so you're like, oh, well, let me make sure I don't click on this. Methods of calculating file hashes. We have these very common hash algorithms, MD5, SHA-1, and SHA-256. And then when you just do MD5 sum inside of the terminal of a Mac OS, which is Unix-based, or Linux, when you use these commands inside of Linux or Unix-based computers, then you give it the file name or the file path right afterwards, and then it'll give you the hash value for it. Inside of the Windows operating system, you can use a commandlet for PowerShell, which is, I think, get algorithm or something like that, or get file algorithm, if I remember correctly, and then you give it the path to the file, and then at the very end you say algorithm SHA-256 or algorithm SHA-1, and it'll give you that value. These are now considered insecure, these two right here. So you will not find them commonly in modern applications or anything of the sort. One of the examples that I give all the time is that when you go to this little button right next to a URL, click on connection is secure, then click on certificate is valid, and you will end up seeing the SHA-256 fingerprint of the certificate, the asymmetric certificate that's used to encrypt the connection to TryHackMe, and it's a SHA-256 fingerprint. So that is the most, I'm not going to say it's the most secure encryption, but it is kind of like the common standard across the board right now, until it becomes very popular to start using quantum encryption, because quantum computers can now decrypt these types of encryption standards fairly easily, but they're not accessible by very many people, because I think there's like a handful of quantum computers across the world right now. So thankfully, your average hacker can't get access to something like that yet, right? So we'll see how the world plays out. So the first two types are now considered insecure or prone to collision, meaning that two or more inputs, two or more files, can have the same hash because there aren't enough variations of MD5, right? There aren't enough variations of SHA-1, therefore SHA-256 is kind of the best common standard right now. A collision attack for these hash functions is not very probable. It's still possible. Therefore, SHA-256 is considered the most secure method of calculating file hash. And we can see that multiple utilities calculate file hashes for us. What we can use is imp hash is one of the big ones. It stands for importing the hash. And imp hash are functions that an executable file imports from other files, or DLLs, dynamic linked libraries. The imp hash is a hash of the function and the calls or libraries that a malware sample imports and the order in which these libraries are present in the malware. And it can identify samples from the same threat groups or performing similar activities. And more information is on the Mandiant blog, available for you at the Google Cloud blog. Actually, yeah, cloud.google.com, threat intelligence, tracking malware, import hashing, etc. So there's that information. So you can use PE Studio to calculate the imp hash of a sample, and there's a little value right here called imp hash that has the imported hash value that's available for you. Any malware samples with the same imports in the same order will have the same import hash. This helps identify the similar samples themselves. And we can see this right here. This is based on Malware Bazaar. The domain is bazaar.abuse.ch. And you can go ahead and search for this imp hash value, right? So this is what we see right here. And then based on that, it'll give you all of the connected executables that would be for that imported hash value. Malware Bazaar, they have the same imp hash. We can see that all these samples are classified as the same malware family. We can see that their SHA-256 is vastly different and doesn't provide any information as to their similarity. However, the same imp hash helps us identify that they might belong to the same family. So the import hash value imports a bunch of different things, and if they fall under the same import hash value, even though they have unique hashes themselves, but they fall under the same imp hash value, which means that they are connected somehow. Fuzzy hashes, SSDeep, another way to identify this is the context triggered piecewise hash, CTPH. This is calculated by dividing a file into pieces and then calculating the hashes of the different pieces. This creates multiple inputs with similar sequences of bytes, even though the whole file might be different, and more information can be found at the website that we have here, which is the ssdeep-project.github, and you can go ahead and read about SSDeep over there. Multiple utilities can be used to calculate SSDeep, like CyberChef. However, this has been placed on the desktop to make it easier, which is the SSDeep utility, and we can just refer to it by using its executable. We do need to actually go either inside of the folder that holds it, or we just need to reference the entire path where it is. And then you can do -H to get the help menu, and it'll give you all of the different usage options that are available for it. And we can calculate the hashes of all of the samples in our mal directory by using this little wildcard character, which says basically run this, right? So run this executable on everything inside of this directory, because the wildcard character could be replaced with A, B, C, D, E, F, G, or it could be replaced with 1, 2, 3, 4, 5, 6, etc. So when you do that, you can now run it against everything inside of the mal directory. Excuse me. And so now you can see all these various hash values for mal1, mal2, mal3, etc. So quite useful. We can try other options that can help the file per the requirements. We have these SSD hashes. We can match these together to identify similar files. This helps us identify similar files if we have a bulk of data. The documentation link is also a good example of this that we just saw right there on the GitHub page for the SSD tool. What we can see below is everything that we have relevant to our use case to match the file. So we can use the -D operator, the -R operator, which runs this recursively, and the L operator to output everything relative to the actual file itself. So you can see now they've used multiple flags here, or multiple options, and we're going to look at everything. What is it? So it literally, I think, is just running it. I don't think it's looking at incoming, outgoing, trash, outgoing corporate espionage, etc., etc. Yeah, I don't think they've attached anything to it. I think they're just running it with these options, and then it's going to search through the entire computer. The results show files that match with each other. The number in the bracket at the end is the percentage of the match along the file. So if we look at the number, yeah, so this is exactly what it is. Maybe actually this is what it is. So incoming, outgoing, and trash are the options that go along with SSDeep right here. And then this is the first line. So this is an outgoing, and then that's what we have right here as the percentage value. This is outgoing, and then this is inside trash. So, okay, that makes a little bit more sense. So in the samples that are located in the mal directory in the attached VM, which of the samples has the same imp hash as file 3? So we'll look at that. And using SSDeep, what is the percentage match of the above mentioned files? The files that we have right here, I'm assuming. So first we're going to run the imp hash the tool to detect the imp hash for all of the files, which I feel like it should actually be right here, because I think all of these things have been done for us already. It's like I don't need to rerun it because it's already running it against all of these things. So now I just need to try to find the ones that potentially match, but I mean none of these match. So that's another thing that's a little bit concerning here. So let's see what we can find here. Okay, so this is what I believe is the command that we're supposed to be using here. So we're going to be using this command, and then we're going to give it this piece right here. So this is just running SSDeep against the malware contents, and it's going to get us the hash values, etc. But if we want to see which ones match each other, we would use this specific command right here, and then we would just give it the malware location, the malware analysis location. So I'm going to go and see if I can actually do this, right? So if I go back to our desktop, because in the desktop is where the SSDeep location is. Yeah, exactly. So we're going to clear the screen. Let's zoom in a little bit for you here so you can kind of see what's up. So we're going to do this, and then we're going to copy this. Okay, perfect. There you go. There's that. And then now we're going to give it the malware /* so that it analyzes everything inside of that. And there you go. Okay, cool. So it says malware 3 matches malware 1, and at a 93% certainty level. So it says which one of the samples has the same of file 3, and that would be 1. And using the SSDeep utility, what's the percentage match of that, which is 93? Okay, perfect. There you go. That's how we get the answer. So we had to get this specific command right here, and then we were supposed to use it against the contents of the malware folder, because in this case, just to demonstrate it to us, they're running it against incoming, outgoing, etc. But we just needed to run it against the actual malware directory, the contents inside of the malware directory. All right, cool. Let's look at signature-based detection. Now, even though hash values can actually be very useful, they are not the be-all and end-all for trying to figure out whether or not a file is malicious and if it is a file of interest. And the way that we can go ahead and really truly figure this out is by looking at the signature of the file. And the idea here is to find a way to identify some files if they are actually similar, and if a file contains the information that we need, the information that is of interest to us. Therefore, the hashes themselves are not the most ideal way to try to find this. So this is where signatures come in. So this is a way to identify if a particular file has a particular type of content, and we can consider a signature as a pattern that might be found inside of a file. And it's often a sequence of bytes in a file with or without any context regarding where it's been found. So security researchers often use signatures to identify patterns in a file, identify if a file is malicious, and identify suspected behavior and malware family. And then signature-based detection is also known as heuristic detection. And this is one of the more powerful ways that security appliances do the jobs that they need to do. Instead of looking at hash values, which again can be useful, but sometimes they don't tell you the full story, the stuff that you need, because someone could just modify the contents inside of the file without actually changing the functionality of the file. But they can add a comment at the end of the file, and that'll change the hash value of it. And if that changes, then now you have a new hash value, and now you whatever detection mechanism you have in place, it's not going to do anything for you because the hash value has completely changed. Therefore, it can't be used to detect the malware itself. So the rest of the source code, the rest of the contents of that file, even though you added the comment at the end of it, the rest of the source code is not going to be different. And this is where signatures are really helpful. They actually look for the patterns inside of the content of the file to see if it is malicious. Yara rules are one of the more powerful ways of doing this. This is a signature-based rule, and it was called a pattern matching Swiss Army knife for malware researchers. And it can identify information based on binary and textual patterns like hexadecimal and strings that are contained inside of a file. We have a dedicated room for this inside of TryHackMe. I'm pretty sure I've already gone through this because I've done multiple videos on Yara rules. Yep, this is the one that I've already done. So you can actually go ahead and find the Yara videos. There's multiples of them, but that one specifically you can go ahead and find to see how Yara rules work, how you can write them, etc. And there's a repository of open source rules that we can use as per our needs. Essentially, you could literally go ahead and just copy paste the contents of these rule files. There's a lot of them, and you can use these various rules in your own environment to see if anything that you have or if anything that comes in through the network connections or the traffic will trigger any of these rules. And that way it can just make your life honestly much easier to detect something while it happens or before it happens, etc. So when we analyze malware, we can use this repo to dig into the community collective wisdom. However, while using these rules, please keep in mind that some might depend on context. Others might just be used for identification of patterns that can be non-malicious. So just because a rule hits doesn't mean that the file is malicious. So keep that part in mind. For better understanding, you can read the documentation for the particular rule that you want to use to identify the use case, whether or not it will actually be useful to you. Proprietary signatures, also relevant to antivirus scans. These are the ones that can actually be developed for your specific environment. You can create a proprietary signature. And the advantage of this is that since they have to do with and sold commercially, right? So this is one of the things, right? When you buy a proprietary signature or a set of rules that have been designed for proprietary signatures, or signatures that the rules themselves, the rule files, are proprietary, there are lesser chance of false positives, right? So this might lead to a few false negatives, right? So you use the rule, it doesn't detect something, and whatever is happening bypasses the rule, and now you have a false negative, meaning that the detection mechanism, whatever tool you're using, said that, oh no, this is fine, this is not malicious, and it was a false negative, and the malicious file does not hit any signature, right? So antivirus scanning helps identify if a file is malicious with high confidence, and these types of softwares mention the signature that the file has hit, which can hint at the functionality of the file. But we have to note that despite the best efforts, every antivirus product in the market has some false positives and false negatives. So when analyzing malware, it's prudent, right? It's useful, it's a good practice to get a verdict from multiple products. And this is where VirusTotal comes in. This is why I love VirusTotal so much, because they literally have, I don't know how many dozens of different resources. So let's say we go, let's say google.com is the URL that we want to scan. And so we scan URL google.com, and currently as it stands, there are 97 antivirus tools that are used to detect different things, different characteristics or details of the URL. And as you saw on the homepage right here, we can attach a file and it can analyze the file for us, as well as obviously the hash value of the file. We can go ahead and search for a URL, an IP address, a domain name, or a file hash, and then you can obviously just search for the URL itself. So there are a few different ways that you can use VirusTotal to search. You can also sign up for VirusTotal account, get access to an API key, and create automations where the script will run the hash value or the signatures of the files that you're looking at against the VirusTotal database and let you know whether or not that is actually a malicious file or malicious URL. I've developed one of these scripts for our Hackaholics Anonymous members, and they have access to it because of the fact that they're an agent level member or above. So agent, guardians, and masters inside of Hackaholics Anonymous get access to those scripts that I create for them. And one of the ones that I created actually does exactly what I just described. We go ahead and we query the VirusTotal database using an API key that you would get from VirusTotal, and it'll scan your computer for anything that might match any of the database contents of VirusTotal to see if anything comes up as malicious. So we can find verdict about a file from, it says 60 plus antivirus vendors, but as you just saw, it's over 90 right now because they keep adding more and more. And we can always, we've already talked about this in malware analysis. So anyways, when you're analyzing a sensitive file, it's best practice to search for its hash on VirusTotal or some kind of other website, for example, the Bazaar that we looked at earlier. And this is to avoid leaking sensitive information on the internet and letting a sophisticated attacker know that you are analyzing their malware. And we've covered Yara rules in the Yara room and VirusTotal scanning in the intro to malware analysis. And there's different videos that I've done. I've done multiple videos, probably about a dozen by now, that we've used VirusTotal as our reference for whether or not a hash value or a domain name is malicious, whether or not a file is malicious. So Flare VM has another very cool tool that will allow us to do something like this, and it's called Kappa. And this tool helps us identify capabilities found in a portable executable file. It reads the file and tries to identify the behavior of the file based on signatures like the import signatures, or import strings mutexes. That's new. I've never even heard of that before. And other artifacts that are present in the file. We can go ahead and look at their GitHub page or their blog post. I am so curious what mutexes means. So let's see what that actually is. It is short for mutual exclusion locks, and they're synchronization mechanisms that ensure only one thread or process can access a shared resource at a time. They're used to prevent race conditions where multiple threads try to modify the same data simultaneously, leading to unpredictable results. That's very interesting. I've never heard of that before. It's kind of cool. That's kind of cool. Where I just learned something new live in real time while I'm recording for you. Using Kappa is as simple as referencing it, calling on the tool, and then giving the location or the path to the malware, the binary, the executable that you're trying to scan. And in this particular case, because we are scanning PE files, they're portable executable files, so we're going to be scanning something that has the exe at the end of it, right? So you can always use the -H to look at the help menu for Kappa, which is a very cool tool. I think I've done a video on Kappa before as well. It sounds really familiar. We can run it against the binaries inside of the mal directory, and it may take some time to complete the analysis, and this is what we have as an example for the very first binary. So we have the hash values here. I've definitely used Kappa before because I recognize this. So the MITRE attack technique that would be relevant to what the actual binary, the malware does. The MBC objectives and the MBC behaviors definitely have looked at this before. So I definitely recognize this. It has mapped identified capabilities according to the MITRE attack framework and the malware behavior catalog. In this, we saw that the capabilities against the matched signatures and the number of signatures that have found hit against these capabilities. And we can see it also tells us if there are obfuscated stack strings in the sample, allowing us to identify if running floss might be helpful. To find out more information about it, we can use -V or VV for verbose or very verbose, which basically gives you a bunch more details, right? So what you see right here is not the verbose version. So all of this information that you see right here is the non-verbose version, and then you can get even more verbose output to be able to get even more details about what you're running. So we're going to run these questions now, and it should be interesting. So let's see. The first one is, how many matches for anti-VM execution techniques were identified in the sample? So I'm assuming that we're talking about, oh no, I see. We're going to be looking at malware 4 to answer the following question. So first, I'm going to run Kappa on malware 4, and then I'll let it finish because it's going to take some time. And then based on that, we'll go ahead and answer the questions that we got. Oh, I hope my virtual machine didn't disconnect because I didn't get any notifications for it. So let's see if we can establish our connection. That would suck if it disconnected. So I'm going to open up our CMD, our command, one more time, and then we're going to run kappa to make this whole thing work for us and get all the information that we need to answer these questions. So here's our command prompt, and kappa is obviously a very simple call that we just make by doing kappa like that. So first I'm going to go into the desktop for the administrator. We are going to list the contents of the desktop, and we have the mal folder, and we want to run it against mal4 that's available for us here. So we're just going to do kappa, and then we're going to do mal\4, and that's basically it. And I'm going to press enter. It's going to take a minute, and then it'll go ahead and generate everything we need for us. I did not do verbose or very verbose. I don't know if that'll make a difference. We'll find out soon enough. Hopefully we'll be able to get all the information that we need by just running it normally without actually running very verbose or verbose. So it's loaded, very good. So now we're just waiting for the analysis portion to finish. And so that's what it's doing right here, right? So it has loading 100%, matching. It needs to also get to 100%. So right now it's still doing its analysis portion. So I will give this a couple of minutes and we will come back when it's done. Okay, so that took maybe 15 minutes, I want to say. So it took a bit of time, and now we have all of our results. Now it says how many matches for anti-VM execution techniques were identified in the sample. So anti-VM execution techniques is what we're looking for. And you can see right here that we have, let me see if I can zoom right here. The matches that we have right here for capabilities. So anti-analysis, anti-VM detection, I guess. And so let me see if there's anything else, but anti-VM execution right here, execute anti-VM instructions. It says 86. I wonder if that's the number. So let's try 86 here. Very good. That's the answer. So does the sample have the capability, I guess, to suspend or resume a thread? Answer with Y or no. So to suspend or resume a thread. Let's see if we can find that. Towards the bottom, we have resume thread 2 matches. So we're going to say yes to that one. What MBC behavior is observed against the MBC objective anti-static analysis? So if we go over here to the top right here, so we have MBC objective, and then we have anti-static analysis, and it's looking for the behavior. So disassembler evasion, argument obfuscation, etc. So I think we also need to give it the ID at the very end. So disassembler. Okay, very good. And at what address is the function that has the capability check HTTP status code? The function that has the capability check HTTP status code, and I think it's under capability. So at what address? And the address would be the namespace that they're talking about. So the check HTTP status code is right here, and the address is communication HTTP client. So what do we have here? Okay, so I stand corrected. The namespaces are not the addresses. And the hint that we got right here is to run it with verbose or very verbose and output it into a file and then go ahead and look at the results. So now I have to rerun this, which I'm going to do with just basically using the same command that I had before. And then what we can do is do one of these forward arrows right here and then just give it a name of a file. So we'll just do analysis, I guess, .txt, and that'll be our output file. And oh, you know what am I doing? I literally have to do the, oh, look at that, it happened very quickly. So, oh no, it didn't. I thought it did. And I need to do a very verbose option with this. So we're going to do kappa, and then we're going to add the very verbose at the end, or verbose, I guess. I'll just do verbose just in case it makes it a little bit faster. and then we're going to do it the analysis.txt. I wonder if, did it happen? That was very quick. Oh no, it barely just started. So it's going to take however many minutes, I guess. And so I have the analysis.txt file over here. I wonder if also, no, it's not. It's not already updating. So we will see how long that whole take. It probably is going to take another like 15 minutes or maybe even longer. So we'll see how this goes. Okay, we are done with the kappa. And so let's now look at the analysis file. And okay, cool. Now we have information here. And what are we looking for? We're looking for check HTTP status code and the address for it. So you can do a few things here. We can actually go through view, what is it, or format, edit, find. There we go. So Control F, but I'm on a virtual machine. Usually it doesn't work for me on Windows machines. So I'm looking for check HTTP, and my keyboard went to sleep because this took so long. So check HTTP status code is what I'm looking for. And there it is. So we have that, and the matches, I guess, would have this right here, namespace, scope, matches, and then encode using data, using etc. So I mean, I guess that would be the one, the matches part, because now it's going used to the different capabilities. So let's see if this is the answer. I hope it is. Let's see if that's the answer. Yep, that is the answer. So the matches right here, that's the address that they're looking for. And we are now done with that one. So now we can move on to leveraging the PE header. For this one, we're going to be using PE Studio, and the PE header and everything inside of the PE header is something that we went in depth for inside of the very last video. PE stands for portable executable, which are these executable files, and they consist of a sequence of bits stored on the disk. And the sequence is in a specific format, and initial bits define the characteristics of the file and explain how to read the rest of the data. And this initial part of this PE file is called the header. And inside of the header, there's a series of different information. And this is where like a lot of the nuanced details that I was referring to at the beginning of this video, this is where a lot of it came in, because for the most part, I mean, most of it went over my head because I didn't know what it was. And I was like learning as I was recording. And now I've been exposed to it through multiple videos, so I'm a little bit more familiar with it. So if you don't get it on the first attempt, if this is like your first time watching this or hearing about what PE headers are and everything, don't judge yourself. Don't be too critical of yourself, because it is a concept that requires exposure on multiple instances for you to really get it, for you to really kind of wrap your head around it. So it's not that big of a deal if you don't understand all the details and everything like that. We're going to be trying to find certain information inside of the PE header using PE Studio, and it's one of those tools that can help us analyze PE headers. And PE Tree was another tool that we used, which was a command line tool, and we used that inside of the analyzing or dissecting PE headers video. So the header inside of a portable executable contains information that's useful for malware analysis. And one of the big things was the various commandlets that were inside of it. So it would actually list all of the different elements that are being imported, the linked libraries and imports and functions that are being pulled into the executable file. And it's inside of the header. So all of that stuff that's being imported, I think it was like under the descriptions or something like that, where we actually saw it. The PE file doesn't contain all the code, so it reuses code from libraries and it imports them, right? And a lot of these things are a native part of the Windows operating system, and the functions from these libraries are imported, and the header contains the information about the libraries that the PE is actually using, the executable is using, and the functions that are being imported from those libraries. And this ends up becoming very useful for us because we can tell just from the stuff that's being imported what the executable is trying to do, right? What the functionality of the executable is, what the functionality of the malware is. So for example, if it imports the create a process function, we can assume that it's trying to create a process, right? So there are other functions that provide information about the sample, And it's something that we don't know the context in which these functions are called just by looking at the header. So we need to dig deeper into it to try to see what it actually does. And we'll be doing it in the future videos because this is literally the last main section of this particular video before we get into the wrap up. And so we'll be doing it in future videos. So this is what PE Studio looks like, right? You have the left pane and then you have the right pane. And inside of each individual section right here, you have more information. So if we click on libraries, it'll show us the dynamic link libraries that are being pulled. And then under the description, we'll see what those individual libraries are actually good for or what they try to do. And then there's also functions that will tell us more information about the individual commandlets or the individual functions that this specific malware is trying to call. For example, exit process, get time zone information, get local time. Let's see, terminate process. My dog just hit my my windows, not my windows, I wonder if it actually cut the video for a couple of seconds as well, because on my actual screen the video got cut because my dog hit my wires, my HDMI wire. So anyways, these are just some things that are pulled up, right? So exit thread, create thread, fatal app exit, etc., etc. So those are called functions, and these functions are pulled from individual libraries. So if you actually see, it's kind of tough to see right here, but it says kernel 32 DLL. So if we actually look at the library list again, we see that kernel 32 DLL is available over here, and dedicated to this DLL are 153 functions, and in total there are 422 functions that have been imported by this specific executable file. Then there's the concept of the packed executables, which is another thing that we talked about in the last video. And packed executables typically are, or the creator of the malware understands that you can actually find the information about these, what the executable can do through static analysis. So what they do, they try to kind of mitigate or try to evade analysis by packing the original sample inside of a shell type code that, again, obfuscates, right? It disguises the properties of the actual malware, and it's called packing in this particular case because the PE file is now called a packed PE file, which reduces the effectiveness of some of the malware analysis techniques that we've talked about so far. And if we try to search for strings in a packed executable, we probably won't be able to find anything. And searching for similar samples using SSDeep will probably return sampled packs with the same packer instead of the actual samples that behaviorally similar to the sample of interest that we actually have. So signatures might also be evaded due to a malware sample being packed, right? So everything that we've talked about so far can technically be evaded if the malware author packs the contents of the malware. And then if you try to look for hash values or signatures, the only thing that will pull up is signatures of other packed malware instead of actually pulling up signatures of individual functions or commands inside of the malware. And when we go into dissecting PE headers, which is going to be a future video, I think it's the next video that I'm going to end up making, we can identify packed executables by looking at the header of a malware, and then the header contains information like the number of these sections, the permissions of different sections, sizes of the sections, etc. And then you'll end up seeing that like the names of the sections could be blank, or the sizes of the sections would be like noticeably much smaller than anything else because it's been condensed, right? It's been packed. Think of it as turning it into a zip file, right? Like you turn all of the contents of the malware into these packs so that you can't see just off the top what those contents actually include, and it also reduces the size of the various elements of the malware. So it can give us pointers to help identify samples that are packed, and if they are, which type of packer has actually packed the executable. So we're going to open up the malware for PE Studio and to see which library has actually been marked as blacklisted, and then what does that specific library do, which is most likely going to be inside of the description of it. So the PE Studio, I basically searched for PE Studio in File Explorer because I couldn't find the location of it. And the path seems to be that it's in Program Data, Microsoft Windows, Start Menu, Programs, Flare, Utilities, and it seems to be over there. So I'm just going to double click on that. and it'll open up PE Studio for us, and then we'll go ahead and open up the malware sample 4 inside of it, and then we'll be able to look at the contents that we need. So you go to File, Open File. This part is like very simple with any other application that you would use in Microsoft. All of those things work exactly the same. So now I'm going to go in the left section right here. I'm going to go inside of my desktop for the administrator user. Inside of that, I'm going to go inside of the mal folder, and then I'm going to open up 4. Now, interestingly, there was also 4viv, which was something that I noticed, and I wonder what that was, but we will not be distracted in this particular case. So this is loading, and I think like as we wait, it's going to load more information because it says waiting next to a lot of these things. So I'm going to give it a couple of seconds or minutes or however long it takes for this to fully load, and then based on the final information, we're going to look at the library that's been blacklisted inside of the libraries section, which is currently still waiting to load. And then from that, we're going to also get the description of that library. Okay, cool. So here we go. We have the libraries loaded. Oh no. And the freaking thing started shutting down as soon as I was ready to go. That's insane. Okay, so now I got to give it a second to load. Okay, I had to go through another restart of the virtual machine because it loaded everything and then it crashed on me. So we have the libraries right here, and there they go. And so let's remind ourselves of the question again, which is asking for which library is blacklisted. And this is the only library that has blacklisted, which is RPCRT4DLL. And we would need to try to find the description of that, which is remote procedure call runtime. So first we're going to type the name of it, which is RPCRT4.dll, and then the description is remote procedure call runtime. And with that, my dear friends, we are officially done with all of the questions here. All right, so far we have learned about basic static analysis, that you need obviously a malware analysis lab environment. So Flare VM is the one that we use because it is a Windows based and it has a graphic user interface and it's pretty decent. Remnux, which is the management or the malware, the reverse engineering malware version of Linux, I believe also has a graphical user interface. It just depends on which one you're most comfortable with. And I think, things like PE Studio as well as PE Tree and Kappa and all those things are available inside of Remnux, as well as, obviously, as we just saw, Flare VM. So that would be the lab environment. And you would want to do that for any kind of malware analysis activity because you don't want to put yourself in a situation where you, number one, mess up your main computer. And then number two, it's like you want to have the downloaded version of this thing, or at least the ISO image, and then run it, do whatever you want with the malware analysis, especially when you're doing static analysis, what we just did, because we weren't technically running any of the malware. We were just analyzing each one of those files inside of these different tools. So that technically counts as static analysis. When we go into dynamic analysis and we're going to start running these malwares, it emphasizes the importance of a lab environment even more in that kind of a situation. Searching for strings and obfuscated strings is what we did. Fingerprinting malware using hashes and identifying similar samples of the imp hash and SSDeep is also what we did. Signature-based detection with Kappa, and then of course identifying artifacts from the PE header. We did all of these things using tools, right? We didn't run strings and then just look at all the strings that came out. We looked at string values inside of a tool, and that made it easier for us. So to kind of put you at ease a little bit when you go into malware analysis, even if you don't have a background in malware analysis, as long as you have a decent understanding of what you're looking for, these tools will help you filter and parse through all of the contents of the malware to get you that data. And then from there, you kind of can determine what things might be relevant to malware analysis techniques and your specific investigation in your particular use case. So whatever that may be, whatever it is you might be looking for, these tools make it easier for you to find them. And hopefully that puts you at ease a little bit, because it definitely puts me at ease. I'm not a fan of reading line by line the output of the terminal and these various different tools that are just, they seem very tedious to try to go through line by line of output of a code and things like that. I enjoy doing that on the offensive security side because it actually makes me feel like a hacker to use the terminal and run these different tools. But when you're talking about analysis, there's so much stuff to analyze, and I don't like looking at just line by line by line by line of data. I want to use a tool that will make that process a little bit easier for me. And you just saw that we actually used several of those tools. So what we're going to do in the next video is we're going to continue along with this type of process. I think the next video is actually going to be an exercise that we're going to run for static analysis, and it's kind of like an actual practical exercise. And after that, we're going to go into dynamic analysis, I think, right? Don't quote me on that, but I believe that's what's in our future. So hopefully you found value from this particular video in this particular room. I'm going to click on complete so that we can go ahead and wrap this one up. And then I'll give you a couple of little notes real quick, and then we'll wrap the video officially. If you found value in this video, and if you found any value from this channel, I do encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out on this channel, especially as we wrap up SOC Level 2, as we go further into Pentest Plus, which is drops every Friday. A new episode comes out every Friday for Pentest Plus, and then at the very, very end of it, I'll do like a bulk upload of all of the episodes so that for the people who like the bigger videos, you'll be able to find those as well. And then we're going to go into AI for cybersecurity, and then CYSA Plus, because I got a request from somebody to do a series on CompTIA CYSA Plus. So there's a lot of content that's going to be coming out, and I don't see it slowing down anytime soon, because this world is constantly evolving, and it's one of those things that I don't think we're ever going to run out of things to talk about. And then we're going to end up doing interviews with other professionals in the industry, other hackers in the industry, which I think is going to be really, really exciting for people who like the podcast type content, because we get to really look at people who are really deep in the game that are actually doing these kinds of things, and get to see what their situation is like and what their experience has been like, what they can teach us. So it's going to be really exciting. I'm super excited for the future of this channel, and I would love for you to tag along on this journey with us. So make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. And of course, if you have any questions or anything, drop a comment, and I will get to your comments as soon as I see them. If you're serious about your CySec education and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comments section. And that is it for today. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you, and I will see you in the next video later.